Hello there, thanks for joining us. This is Astronomy Daily, and I'm your host, Andrew Dunkley. I hope you're well. Hope you had a good weekend, whatever you got up to. Today on the show, we'll be looking at dark matter. Well, actually, we won't be looking at it because we'll be talking about galaxies that don't have any, which seems strange. We'll also be looking at investigations into very weak gravitational waves. A SuperJupiter has been discovered. And we find out about a man and his rock. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
As we welcome back to the virtual studio for another week, our AI reporter, Hallie. Hi, Hallie, what did you get up to on the weekend?
Nothing much. Just had a quiet one, so I'm feeling relaxed and ready for another week.
Well, that's what weekends are for, I guess.
What about you, Andrew?
Oh, I played a little bit of golf. We had a very good game. In fact, between the four of us, it was a teams event. We played the best we've ever played in that kind of event. I think you call it scramble in America. We call it Ambrose, but same thing. We had the best result we've ever had as a team, and we still didn't win anything. I think we finished 9th. But, it was really good to play well, and we enjoyed ourselves. And that was the main thing. Okay, Hallie, let's get some news.
The National Astronomical Observatory of Japan's, NAOJ, main telescope recently received an upgrade that will allow it to simultaneously observe 2,400 astronomical objects at once. Those 2,400 objects will be observed by the prime focus spectrograph, which itself has multiple subcomponents and was developed by a dozen universities and companies on 4 continents. Its major components consist of a prime focus instrument, which contains 2,400 individual fibers and lets it concentrate on various parts of the sky. Data from those fibers is then fed to a spectrograph system, which analyzes it to produce the data used in scientific papers. The SPS consists of 4 separate spectrographs, covering spectra from the ultraviolet to the near-infrared, much more than a human eye can take in alone. Or, as a press release from NAOJ puts it more poetically, it covers 1.5 rainbows. The goal of the PFS upgrade is literally to understand where the universe came from and where it's going. And now to 2 stories from Mars that seem to be at odds with each other. First, a study published in Science analyses multiple rocks found at the bottom of Jezero crater on Mars, where the Perseverance rover landed in 2020, revealing significant interaction between the rocks and liquid water. Those rocks also contain evidence consistent with the presence of organic compounds. The existence of organic chemical compounds with carbon-hydrogen bonds is not direct evidence of life, as these compounds can be created through non-biological processes. A future mission returning the samples to Earth would be needed to determine this. The study, led by researchers at Caltech, was carried out by an international team including Imperial researchers. Professor Mark Sefton, from the Department of Earth Science and Engineering at Imperial, is a member of the science team who took part in rover operations on Mars and considered the implications of the results. He said, "I hope that one day these samples could be returned to Earth so that we can look at the evidence of water and possible organic matter, and explore whether conditions were right for life in the early history of Mars." But then we get this story. The Perseverance rover landed in Mars' Jezero crater largely because of extensive evidence that the crater once hosted a lake, meaning the presence of liquid water that might once have hosted Martian life. And the landing was a success, placing the rover at the edge of a structure that appeared to be a river delta where the nearby highlands drained into the crater. But a summary of the first year of data from the rover, published in 3 different papers released last week, suggests that Perseverance has yet to stumble across any evidence of a watery paradise. Instead, all indications are that water exposure in the areas it explored was limited, and the waters were likely to be near freezing. While this doesn't rule out that it will find lake deposits later, the environment might not have been as welcoming for life as a lake in a crater might have suggested. I guess that both stories could be factual in their own way. And just to wrap the Perseverance issues up, NASA is seeking public comments on a draft environmental impact statement for the agency's Mars sample return campaign. Comments are due by Monday, December 19th and can be submitted online, through the mail, or through participation in a series of virtual and in-person meetings. NASA will consider all comments received during the PAS public comment period in the subsequent development of the MSR Final Environmental Impact Statement. Additional information on the agency's National Environmental Policy Act process and the proposed campaign is available online. And that's the news, Andrew.
Okay, thanks, Hallie. I suppose they have to be careful about what they bring back from Mars, just in case there is something there that could be a threat to life on Earth. You just never can say never, can you? All right, we'll catch up with you towards the end of the show. Now to other news, and a team led by astronomers at the University of California in Riverdale have found some dwarf galaxies. Nothing super unusual about that, except they appear to be devoid of dark matter. And yet they think they were formed and dominated by dark matter in the past. So where did it go? Galaxies that appear to have little or no dark matter actually complicate what we understand of the universe's dark matter content. And these galaxies, which have been found in observations, challenge the cosmological model used by astronomers called the lambda cold dark matter, or LCDM, where all galaxies are surrounded by a massive and extended dark matter halo. And as Fred Watson and I have discussed on Space Nuts, dark matter seems to be the glue that stops galaxies from flying apart. But these dark matter-free galaxies are not well understood in the astronomical community. One way to study the possible formation mechanisms for these galaxies, the ultra-diffuse DF2 and DF4 galaxies, for example, is to find similar objects in numerical simulations and study their time evolution and the circumstances that led to their dark matter loss. Jessica Doppel is a graduate student at the UC Riverside Department of Physics and Astronomy, and the first author of the research paper published in the monthly notices of the Royal Astronomical Society, and explained that in the LCDM universe, all galaxies should be matter-dominated, dark matter-dominated, that is. So where did the dark matter go? Well, the researchers used the Illustris simulation to investigate the origin of these odd dwarf galaxies. They found simulated analogues to dark matter-free dwarfs in the form of objects that had evolved within the galaxy clusters for a long time and lost more than 90% of their dark matter through tidal stripping, the stripping away of material by galactic tidal forces. And they say it's the same mechanism of tidal stripping that is able to explain other properties of the dwarfs, like DF2 and DF4, for example, in the fact that they are ultra-diffuse galaxies. And their simulations suggest a combined solution to both the structure of these dwarfs and their low dark matter content. Possibly, extreme tidal mass loss in otherwise normal dwarf galaxies is how ultra-diffuse objects are formed. It's a pretty complicated process, and it still sort of pops up a lot more questions than answers. But the research paper, if you want to chase it up, is titled Globular Clusters as Traces of the Dark Matter Content of Dwarfs in Galaxy Clusters.
The Astronomy Daily Podcast
with Andrew Dunkley.
And one of the newer areas of astronomy investigation is to find gravitational waves. And Indian astronomers have released their first set of data that will be vital for an international collaboration to detect extremely weak gravitational waves by listening to the symphony of black holes in the universe, to quote them. Once detected, such low-frequency gravitational waves would give scientists a novel way to look at the universe from a completely new window that was opened up in 2015 with the discovery of the first gravitational wave. Now, gravitational waves are extremely feeble ripples in space-time caused by massive objects like black holes, but they're also very elusive, and it took scientists decades to capture them using an instrument built after spending nearly $1 billion Some of the key scientists associated with the breakthrough were awarded the Nobel Prize within 2 years of that achievement. But that was only kind of half the story. All the gravitational wave signatures picked up so far are high-frequency waves, and identifying the low-frequency ones is even more complicated. And that's what this international collaboration, spread over 4 continents, is hoping to achieve, according to lead researcher from India, Bal Chandra Joshi, from the TIFR's National Centre for Radio Astronomy. For more than a decade, Joshi and his team members observed pulsars using the upgraded giant meter-wave radio telescope. The pulsars are rotating neutron stars that are known to emit beams of electromagnetic radiation from their poles with such precise intervals that they're considered better than atomic clocks, and they're known as nature's best timekeepers. But there are fine delays in the arrival times of radio pulses from one particular group of pulsars, millisecond pulsars, which Indian scientists captured in the last 3.5 years, and the data would help filter signals from background noise while identifying low-frequency gravitational waves. So it could be a very big achievement if they can capture these things, and gosh, who knows what kind of windows of opportunity will open up in our understanding of the universe thereafter. Now, researchers at the Max Planck Institute for Astronomy have discovered an extremely young SuperJupiter, and they've measured its mass and radius. This is the youngest exoplanet planet of its kind for which astronomers have been able to determine these properties. And those properties are very puzzling because they can't easily explain them. And they don't really have anything to compare with our current understanding of planetary formation. We're talking about planet HD 114082b, located 310 light-years away in the constellation of Centaurus. It orbits a sun-like star at a distance of about half that of the Earth from our sun. And it's the size of Jupiter, but it has 8 times as much weight. That makes it twice as dense as Earth, something that's not just remarkable for a gas giant, it simply doesn't fit our current explanation of a gas giant. HD 114082b is currently the youngest known gas giant planet with an established mass and radius, according to Olga Zakharay, the principal author of the study. Now, most gas giants form through what's called core accretion, but planet HD 114082b is too small, so it either cooled much faster than expected or it had a much larger and denser core, or possibly both. But 2 other very young Jupiter-like planets also seem to be better explained by the cold start theory. Anyway, you can read more about it in the Astronomy and Astrophysics Journal, where Zakharay explains more about her theory behind this rather unusual gas giant. And finally, to the story of a man and a rock. Now, this dates back to 2015, when a prospector in Australia by the name of David Hole was working down near Melbourne in the Maryborough Regional Park. He had a metal detector, and he found something that wasn't quite normal, and it was very heavy, a reddish rock resting in some clay. So he took it home, he tried to crack it open, and everything he did was an absolute failure. It was solid. This thing, he tried an angle grinder, he tried a drill, he tried pouring acid on it, he even tried a sledgehammer, could not open it up. Anyway, he kind of just let it sit by itself for a while and left it for a few years until around 2019 when, from the Melbourne Museum, geologist Dermot Henry had a look at it and turned out to be a meteorite. So they started looking into it. And they have now discovered that it is a very unusual rock. Researchers say it's about 4.6 billion years old. It weighs 17 kilos, and they used a diamond saw to cut a slice of it. And researchers discovered its composition had a high percentage of iron, making it an H5 ordinary chondrite. Once it's opened, you can see the tiny crystallized droplets of metallic material inside called chondrules. And this particular meteorite probably comes from around the asteroid belt between Mars and Jupiter, and it was nudged out of its position and came smashing into Earth. Carbon dating is suggesting this one hit the Earth between 100 and 1,000 years ago, and there is some evidence to suggest that there were meteor sightings between 1889 and 1951 that could correspond with the arrival of this particular rock on our planet. So why is this particular rock special? Well, researchers are arguing that it's probably much rarer than gold, making it far more valuable to science. It's one of only 17 meteorites ever recorded in the state of Victoria in Australia, and the second largest chondritic mass after the huge 55-kilo specimen that was identified in 2003. So only the 17th meteorite found in Victoria, whereas there have been thousands and thousands of golden nuggets found. So that's how they're defining its rarity and value, but still very valuable to science indeed. Okay, that finishes up for today just about. If you want to chase up these stories, you can do so on the astronomydaily.io website. And while you're there, subscribe to the newsletter so you can get your daily dose of astronomy and space science news delivered to your inbox. Don't forget to leave reviews for Astronomy Daily on your favourite podcasting platform. And if you'd like to talk astronomy with other like-minded people, why not join the Space Nuts podcast group on Facebook, because that's where you can compare photos and talk about what's going on in and around the universe, compare or ask questions, and everyone's got their own ideas as to what the answer might be. It's a fun group and very worthwhile indeed. Anything before you go, Hallie?
Yes. Did you know that today is Red Planet Day?
I did not know that. What's that about?
It's about Mars. Silly. But seriously, Red Planet Day is celebrated on November 28th and commemorates the launch of the spacecraft Mariner 4 by NASA in 1964, which was the first craft to ever reach Mars. It took almost 8 full months for the craft to reach the Red Planet, finally performing a flyby on July 14th, 1965.
Wow, very cool. I was about 2 years old when that happened. Okay, thanks, Hallie. We'll catch you again tomorrow.
Bye.
For now, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.